Hello guys, hope all of you are doing great. This is Dr. RCB and you are viewing my channel Computer Science with Dr. RCB. This is part 4 of the video series where we are learning the Python programming language from the very basics. The link of the video series you will get in the description section. You can check it out but after watching this video. In this part of the video, we are going to learn conditional statements in Python programming language. First, I'll be telling you the rules of the game and then we'll do some actual coding. And also, at the end of the video, there will be a check your understanding session. I have added the time codes in the description of the video. Using that time codes, you can browse the content of the video as you wish. Okay guys, then let's begin today's part. When you write a program, it's very common, almost always, that the program has to take some decisions and do certain things based on the decision. Say you write a program that takes the average mark obtained by a student, say 87.09, and outputs the letter grade obtained by the student, in this case, say A+. It's easy to comprehend that the program has to do some comparisons at some point to decide in which range the average score lies. And based on the range, it has to print different grades as its output. Our today's tool, namely if, elif, and else, comes in handy whenever your program has to take different actions based on some conditions, and hence they are known as conditional statements. Let's learn how to use them in a program. Say you are writing a grading system where the grade is A+ if the average mark is greater than or equal to 50. Otherwise, the grade is A. For that, first write the keyword if and then write the condition you want your program to check. In this case, it is whether the average is greater than or equal to 50. Then write a colon. And then write the block of code you want your program to execute when the condition is true. In this case, print A+. Then write the keyword else followed by a colon. Then write the block of code that you want your program to execute when the condition is false. In this case, it is print A. Easy, isn't it? Now it's time for a few key points to keep in mind. These are keywords. You cannot write them in any other ways. That is, if you write them like this, all of them are wrong. However, these spaces before these colons are optional and arbitrary. It means you can give 0, 1 or more spaces before these colons. Another very important point to keep in mind regarding syntax. These spaces called indentation in front of these print statements are mandatory to indicate that they are separate blocks of code. This block is if block and this one is else block. You should realize that these if-else blocks can contain any number of valid Python statements as shown here. Now let's upgrade our grading system to print 4 different grades instead of only 2. Say these are the rules. If the average mark is within the range of 0 to 40, the grade should be C. If it is within the range of 40 to 60, the grade is B. If it is within the range of 60 to 80, the grade is A. And if it is within the range of 80 to 100, the grade should be A+. You already know 2 ways of writing the equivalent Python code. The first way is you can write multiple if blocks without any else blocks. Say you first write a if statement to check if the average is within the range of 80 to 100. If it is the case, print A+. However, if the average is not within 80 to 100, then do not do anything. Rather, write a separate if statement to check a different range, say 60 to 80. And if it is the case, print A. And again, if the average is not within 60 to 80 also, do not do anything. Instead, start a separate if statement for the next range, say 40 to 60. And if it is a match, print B. Similarly, write a separate if statement for the last range, that is, if the average is within 0 to 40, print C. You should realize that these are independent if blocks. That is, the result of one if statement doesn't depend on the result of its previous if statement. Okay, now it's time for the second approach, where you can write a nested if-else statement. For that, you write a if-else statement to check if the average is within the range of 80 to 100. And if it is the case, print A+. Up to this point, everything is same as the previous approach. However, this time, instead of writing a new if directly, we would write a new if statement only when the previous if was false. That is, we write an else statement first, and then inside the else block, we write another if statement to check if the average is within the range of 60 to 80. And if it is the case, print A. And if the average is also not within 60 to 80, we write an else block for this inner if statement. And inside that else block, we write another if statement for the next range, say 40 to 60. And if a match is found, we print B. If the average is not within 40 to 60 also, we write the else block of this most recent if. And inside that, we write another if to check if the average is within 0 to 40. And print C if it is a match. Otherwise, if the average is not within 0 to 40, it means the average is either less than 0 or greater than 100. So we have to write another else for this innermost if. And simply print invalid average inside this else block. See, one if else, inside that another if else, and inside that another if else, and inside that another if else. And hence a nested if else. Although both these ways are right, we still can do better with elif. And that is the third way of writing the program. For that, first write the if statement as usual, that is, write if the average is within 80 to 100, print A+. Then instead of writing an else, write the keyword elif, followed by the next condition. In this case, whether the average is within the range 60 to 80, and if so, print A. If the average is not within 60 to 80 also, then write another elif to check if the average is within the range 40 to 60. And if so, print B. If the average is not within 40 to 60 also, write another elif to check if it is within 0 to 40. And if it is the case, print C. If the average is not within 0 to 40 also, certainly it must be less than 0 or greater than 100. To handle this situation, we simply write an else block to print invalid average. Now it's time for another few key points to keep in mind. An if is always followed by a condition and then a colon. An elif is also always followed by a condition and then a colon. However, an else is never followed by a condition, rather directly by a colon. Congratulations, you have learned all about if, elif, and else in Python. Now it is coding time. Okay, I just explained you a very useful tool in Python programming language that helps you to make your program take decisions. Let's now learn how to use that tool to write some actual programs. Let's start with this simple program. Write a program to check if a given number is even or odd. Display the number is even if the number is even, otherwise display the number is odd. Okay, we need to store a number here. So for that reason, we'll be creating a variable and then there we'll store some numbers, say 34. And then the next question is, how do we decide whether the number is even or odd? Yes, we divide the number by 2 and check the remainder. If the remainder is 0, it means the number is even, otherwise the number is odd. Now, the next point is how we make our program to take a decision whether it has to display the number is even or it has to display the number is odd. And that's where our today's tool come into the picture. Let's see how to use it. The first thing is you have to write the keyword if, and then you have to write the condition based on which you want your program to take a decision. And here the condition is whether x mod 2 equal 0 or not. And then you have to write the colon as part of the syntax. Now, if the condition is true, then what you want your program to do? You want your program to display the number is even. So you'll be writing print the number is even. That's all. And then if the condition is false, that is, if x mod 2 is not equal to 0, then what we want our program to do? We want our program to display the number is odd. So for that reason, first thing is that you have to write here an else to make sure that, okay, this is the part that your program should execute when the condition becomes false. And then you just write there like print the number is odd. That's all. That's your program. Let's execute this program and check the output. The number is even. Since x is equal to 34, it is showing you the number is even. Let's see how it is working. First, it is doing if x mod 2 equal 0 or not. That is 34 mod 2, which is 0. 0 is equal to 0. That is a true condition. Since it is a true condition, it will come inside the if block. That is, it will execute the code that you have written inside this if block. It means here it will display or it will execute print the number is even. As a result, you're seeing the number is even. Now see here, as soon as this if block is executed, it will skip this else part. Okay, let's try with some other number. Say x is equal to 31. In that case, what will happen? 31 mod 2 equal to 0. Let's say false condition, because 31 mod 2 is equal to 1. 1 is equal to 0. That is false. And since it is a false statement, then what it will do? The program will skip the if block and it will directly go to the code that you have written inside this else part. As a result, it will execute print the number is odd. And as a result, on the screen, you will see the number is odd as output. Clear? Okay, let's write this program. Write a program to check if a given number is divisible by 7. Display yes or no. Simple, isn't it? First, we have to store a number. Again, we are declaring a variable x, and let's store 34 there. And then we have to check if the number is divisible by 7 or not. And how do you know that? Again, the same thing. You divide the number by 7 and check the remainder. If the remainder is equal to 0, it means the number is completely divisible by 7. Otherwise, the number is not divisible by 7. Okay, let's do it. And based on that, we want our program to take a decision. That is, if the number is divisible by 7, then we want our program to display yes. And if it is not, we want our program to display no. It means we want our program to take a decision. And that's why we have to use here what? We have to use here if else. Again, the same thing. Okay, first write the keyword if and then write the condition that you want your program to check. Here, the condition is whether that number x mod 7 equals 0 or not. And if this condition is true, then what we want to do? We want our program to display the number is divisible by 7. Here, according to this program, it is asking display yes or no. So we want to display here, say yes. And then if the condition is false, it means if the number is not divisible by 7, then we want to display no. For that reason, what we have to do is we have to first write else to make sure that, okay, if the condition is false, this part should be executed. And then inside that, we'll be writing print no. That's all. This is the program. Let's execute this program and check. See, it is displaying no because 34 is not divisible by 7, I guess. Yes, it is not divisible by 7, right? Okay, let's give 35 and check. Yes, it is displaying an yes. It means 35 is divisible by 7, right? Okay, understood? Simple, isn't it? Okay, now let's try this one. Write a program to check if a given number is divisible by both 4 and 7. Display yes or no. Again, a simple program. First, we have to store a number. Again, x is equal to, say, 34. And then we want to check if the number is divisible by both 4 and 7. See here, checking whether a number is divisible by both 4 and 7 is same as checking whether that number is divisible by 28 or not. We can directly write x mod 28 equals 0 or not. But here, my point is that in a if block, you can write actually multiple conditions. So for that reason, we'll check whether the number is divisible by both 4 and 7 individually. Okay, let's see what I mean. First thing is we have to write this because we want our program to take a decision. That is, sometimes we want our program to display yes, sometimes we want our program to display no based on the input number. That is, our program has to make a decision, and for that reason we are writing here if. Done. If part is done. Now the next question is what condition we want our program to check to make the decision. In this case, we want our program to check two conditions. Okay, two conditions should be true at the same time. That is, if x mod 7 equal 0, that is, the number should be divisible by 7, and at the same time x mod 4 equal 0. See, we are checking two conditions. We want we want both these two conditions to be true. That is, the number should be divisible by 7 as well as the number should be divisible by 4. And if both these two conditions are true, then what we want to do, we want our program to display yes on the screen. Yes on the screen. Okay. Otherwise, that is, else we want our program to display no on the screen. So no. Execute the program and check the output. It's no, because it is not divisible by 7, right? But it is divisible by 4, I guess. Is it so? No, it is not divisible by 4 as well as it is not divisible by 7. So it is showing you a no. Let's say give a number which is divisible by 4 but not by 7. Say 8, and run the program. It is saying still no. It is divisible by 4 but it is not divisible by 7. Okay, let's give a number, say 32. It is divisible by 4, but again, it is not divisible by 7. No. Let's give a number, say 56. Okay, let's see what output it shows. It shows you an yes. Why is it so? See here, 56 mod 7 equal to 0. That is a true condition. And again, 56 mod 4 equal to 0. That is also a true condition. Since both these two conditions are true, the entire statement is true. Okay, as a result, this if block will be executed and it will show you yes. And as you know, if the if part is once the if part is executed, it will completely skip the else part. Okay, as I said, this checking x mod 7 equal to 0 and x mod 4 equal to 0 is same as x mod 28 equal to 0. Let's write the code in that way and see whether really they are same or not. Say number is x again, and let's say store 34 there and write there if, because we want our program to take a decision. And then what condition we want to write? We want to write like x mod 28 this time, okay, equal to 0 or not. And if it is the case, then we want our program to display yes on the screen. Otherwise, we want our program to display no on the screen. It should give you the same output. This program and this program, they are same. Okay, it's no. Say 56 you give, it should give you an yes. And yes. Understood? Now let's try this one. Write a program to check if a given number is positive, negative, or 0. Display appropriate messages for each case. Now see, this time we want our program to take 3 decisions. Whether the number is positive, whether the number is negative, or the number is equal to 0. Right? 3 decisions we want our program to take. Let's see how to do that. For that, again, we want to store a number. So we are writing x is equal to, say, for example, 34. And then we want our program to check. Let's first check if the number is positive or not. Okay, so for that reason, we'll be writing if, and then take the number and compare it with 0. Okay, let's first check whether the number is equal to 0 or not. Okay, you can take any condition first. That's not a problem. We're checking here whether the number is first equal to 0 or not. That is, if the number is, if x is equal to 0, then what we want to do, we want our program to display it's a 0. So zero, 0, that's all. But if it is not the case, then what we want our program to do, see, now you can see, as I said in my explanation part, that you can write whenever you have to take multiple decisions, then you can either use independent if statements, you can use nested if else statement, or you can use elif statement. Okay, so let's use first these nested if else statement. That is, first we will be checking if x equal to 0 or not. If it is the case, we will be displaying 0 on the screen. But if it is not the case, then what we will do is we will write another if block there, and we will check whether this time x is greater than 0 or not. That is, we are checking if the number is positive or not. Okay, see the way I am writing this indentation. You should you should keep it in mind actually. If x is greater than 0, it means the number is positive. So we'll be writing here print the number is positive. Okay, done. But if it is not the case, then what you want to do is you want to write only one option is remaining. See, you check the number is not 0. It means 2 options left. Either the number could be positive number or the number could be negative number. So for that reason, you checked here whether the number is greater than 0 or not. If it is 0, it means the number, if it is greater than 0, it means the number is positive. Otherwise, you don't have to check any more condition. 2 options are already gone. It means only one option left. And that option is the number must be a negative number. The number is negative number. Okay. That's all. I mean, you check the execute the program and check the output. The number is positive. 34 is certainly positive. If you give a 0, and it will display 0 on the screen. You give a negative number, say minus 90, it should show you a negative on the screen, right? Now let's write the same program using independent if statements. Okay, let's do it. Say the number is x, we store there some value, and then we check if x equal to 0, we want to display print the number is 0. That's all. But if it is not equal to 0, we don't do anything here. Rather, what we will do is we'll write another completely independent if statement, and there we'll be writing if x is greater than 0, and then we'll be writing here print that number is positive. And if it is not the case, we'll not do anything here. Instead, we'll write another if statement. And there we'll be checking if x is less than 0, and we'll be printing the number is negative. Okay? And let's execute this program and check the output. The number is positive. If I give here a 0, it will display the number is 0. And if I give here a minus 90, it will display the number is negative. Okay, so this is another way of writing the same program. And the last option here, and the last way, right, I mean the most efficient way is using the elif statement. Okay, let's write it. Again, x is equal to, say, for example, 90. First you check if the number is equal to 0 or not. If it is the case, then we know we want our program to display 0 on the screen. Done. But if it is not the case, then we want our program to check another condition. Okay, so we'll be writing elif, that is, if the previous condition is false, check this condition. And that is why after elif you always have to write a condition. Elif, what condition we want to check next? Say if x is greater than 0, greater than 0, we'll be writing here print the number is negative, positive. Okay, and if it is not the case, then you don't have to check any condition. You don't have to check any more conditions, isn't it? Three options, 2 are gone, only 1 is left, so certainly that is the result. So in that case, you just write else, that is otherwise, that is if the first condition was also false, the elif condition was also false, then certainly this part should be executed. And what we should write in that block, we should write like, okay, the number is certainly negative number. You got it? Okay, let's execute this program and check the output. It's a positive. If x equal to 90, the number is positive. If x equal to minus 90, the number is negative. And if x is equal to 0, the number is 0. Okay, let's try this one. Write a program to display 1 if the given number is 1, display 2 if the given number is 2, display 3 if the given number is 3, and display other number for any other numbers. Clear? Understood? Okay, then let's write the program. We'll be using here this time elif option. Okay, certainly you can write independent if blocks, you can use nested if else statement, and here we'll be using elif statement. Okay, then first your number is say x, and there we store some number say 45, and then this, what we have to do is, if the number is 1, we could have started with this x equal to 45. No problem, that's not a problem. Let's start with x equal to 45. Now what we want our program to do is, if the number is equal to 1, we want to display the text 1 on the screen. For that reason, we have to check. See, again, our program has to take some decisions. So for that reason, we are using if else statement. So if the given number x is equal to 1, we want to display 1 on the screen, the text 1, the string 1 on the screen. Done. But if it is not the case, if we want our program to check another condition, whether x is equal to 2 or not. And in that case, if this condition is true, then we want our program to display 2 on the screen. But if it is also false, then again, we want our program to check another condition. So we'll be writing another elif. And this time the condition is whether x is equal to 3 or not. If x is equal to 3, we want our program to display the string 3 on the screen. And if it is also false, then see, we want our program to take only 4 decisions, whether it is 1, whether it is 2, whether it is 3, or for all the other numbers, it should be 4. It means, see here, if the program is executing this part, it means this condition was also false, this condition was also false, this condition was also false. It means out of 4, 3 options are already gone. Only 1 option is left. So for that, you don't have to check any condition explicitly. Directly you can write else, and then you can write print other number. Okay, let's execute this program and check the output. Other number, because 45 is not 1, not 2, not 3, so obviously it's other number. Any number you give, say minus 45, then also it will show you other number. But if you give here, say for example 1, it should show you 1 on the screen. If you give here, say 3, it will show you a 3 on the screen. Clear? Okay, simple programs, isn't it? Okay, let's try this one. And this is the program that we talked about previously, isn't it? Okay, write a program to display a plus if the number is greater than or equal to 80. A, if the number is greater than or equal to 60 but less than 80. B, if the number is greater than or equal to 40 but less than 60. C, if the number is less than 40. Invalid number for all other numbers. There is no all other numbers in this case, isn't it? Because I said if it is greater than or equal to 80, for all of them, it may be 100, 1050 and all, we should display an A plus. And if the number is less than 40, we should display a C. So there is no question of invalid numbers. This program is slightly different than the program that I used in my explanation. You should be able to, see the difference there. Okay. Let's try to write the code. What we want is, we want to, take the decision based on a number. We need to store a number. So for that reason, we'll be writing x is equal to, say, 34. and display a plus if the number is greater than or equal to 80. See here again, our program has to take multiple decisions, so we'll be using elif statement. First we'll be writing this if, and then we'll take any one of these. You can take actually any one of these conditions to check first. Okay, you can start with this last one also. Let me start with this last one. Okay, just to show you that it can be done from any you can start with any condition. Actually, it is not necessary that whatever it is the first one that you have to check only, you have to start with only that particular condition. Okay, you will come to know when I write this program. See if the number is less than 40. Okay, see if, check, x is less than 40, strictly less than. Okay, if x is less than 40, then what you want to do, you want to display the number is, you want to display a C on the screen, that's all. But if it is not the case, that is if the number is not less than 40, then what you want to do is you want to check another condition, elif, whether the number is, say this time you want to check the first one, display a plus if the number is greater than or equal to 80. Check it, whether the number is x is greater than or equal to 80. This one, this time it is mentioned here like whether the number is greater than or equal to 80. That's why I'm writing here x is greater than or equal to 80. Okay, and in that case we'll be displaying print, say a or a plus here, right? A plus. But if it is also not the case, then again we want our program to check another condition, and let's use this one now. If the number is greater than or equal to 60 but less than 80. Okay, let's write it in this, greater than or equal to 60, that is x is greater than or equal to 60 and the number also should be less than 80. So you'll be writing x is less than 80. In this case, you'll be writing print, what is that? A we want to display on the screen. Okay. But if it is also not the case, then what is left? See here, you have checked out of 1, 2, 3, 4. As I said, this is not like, this will never come actually. Okay, so out of these 4 options, you have checked the first one, the second one, and third one. So only one option is left, and obviously if all of them are false, then the last one must be true. So for that reason, you can simply write an else and print whatever it is that last option asks you to print. And the last option here is if it is not less than 40, if it is not greater than or equal to 80, or if it is not within the range of 60 to 80, then the number must be within the range of 40 to 60. So okay, let's write it then. It is and if it is within this range of 40 to 60, we want to display a B. Okay, let's now run this program and check the output. It is displaying you C. C is 34. X is equal to 34, so it is displaying C. Why it is C? Because the number is less than 40. 34 is less than 40, so it is displaying you a C. Let's give a number, say 340. This time the number is greater than or equal to 80, so it should display you an A plus. It is displaying an A plus. Let's give the number as, say, within the range of 60 to 80. Say for example 66. In that case, we want our program to display A, so it is displaying A. Let's give, say here 80. In this case, we want our program to display A plus. A plus. Let's give here a number which is less than, which is 0. Say if it is 0, it is less than 40, so it will be displaying a C. We have not displayed B. How to display B? If it is within the range of 40 to 60. Okay, let's give the number as 40. So see here, greater than or equal to 40 means B, so it is displaying a B. Okay, understood? Now see here, I have not written this condition in the same order it was asked in the program. See, you should realize that you can take any condition and you can check. The order of the condition that you check is not that important. Only thing is that you have to write them in a proper way using these if, elif, and else statement. You got the point? You just think for a moment and pause the video, think for a moment and try to understand this code. It should make sense. Okay. Okay, let's try this program. Write a program to check if a 3-digit number is equal to the sum of the cubes of its digits. If yes, display Armstrong number, otherwise display not an Armstrong number. Don't worry about this name here, okay? That is not our main concern. Our main point is that we have to write a program that first splits the digits from a given 3-digit number. That is digit 1, digit 2 and digit 3. And then what it does is it computes the sum of the cubes of these digits. That is d1 cube plus d2 cube plus d3 cube. And then it compares that sum with the given number itself. So if both these two things are same, that is if the given number is same as the sum of the cubes of its digits, then we want our program to display Armstrong number on the screen. Otherwise, we want our program to display not an Armstrong number on the screen. Okay, let's try to write it first. Okay, but before that, let's see these examples. Say for example, the number is 153. In that case, 1 cubed plus 5 cubed plus 3 cubed, if you add them up, you will get 153, which is exactly same as the given number. So in that case, we want our program to display Armstrong number on the screen. Another number, say consider 407. So if you compute 4 cubed plus 0 cubed plus 7 cubed, if you add them up using a calculator, you will find that it is 407, which is exactly the given number itself, right? So in that case also, we want our program to display Armstrong number on the screen. However, if you take another number, say 456, in that case, if you compute 4 cubed plus 5 cubed plus 6 cubed, it will not be equal to 456. So in that case, we want our program to display not an Armstrong number on the screen. Clear? You understood the question? Now it's time to write the program. Okay, let's do it. Say we want to store a number first. So for that reason, we declare a variable, and in that variable, we store a 3-digit number. Any random number I stored here. Okay. Should I increase the font size a bit? Okay, let's do it. Okay, this is our, say this is the given number. And then what we want is, actually before using the if else, okay, first what we have to do is we have to do some computation. And what we want to do in that computation, first we want to now separate the digits of this given number. How to do that? Okay, let's say d1 is equal to whatever it is the number, we want to compute the modulo 10, and that way we can separate the last digit. We can take out the last digit from the given number. Okay, done. So that is our last digit that I have stored in d1. It means d1 is right now 5. And then once that last digit is taken out, that is extracted, what we want to do is we want to throw it out from the number. So for that reason, what we have to do is we have to change the value of x to x integer division by 10. Okay, done. And then we want to get now digit 2. So digit 2 is equal to whatever it is x now, perform modulo 10, and then that will be our digit 2. And after that, once that second digit is taken out, we do not need that digit in that number. So for that reason, again, we will change the value of x to x integer division by 10. Now see, you might be thinking like, how do I know all these things? Or I mean, I'm not explaining these things. Why? Because these concepts are explained in part 3 of this video series. And that is another reason actually you should check that playlist out. But don't need to do it right now. Once you finish this video, then you can go there and you can check it out. Okay? Okay, done. Now x is equal to x integer division by 10. Done. And after that, we need d3. Now see, this one will remove the last digit from the number. This one will remove the second last digit of the number. So that way, when we after performing this particular state operation, what will happen is in x, only the first digit will be there. First digit in the sense I'm considering the leftmost digit as the first digit and the rightmost digit as the last digit. So in that case, after performing this particular operation, x will be 5 and that will be digit 3, isn't it? So I can directly write here x. Or if you follow the general approach, no harm will be met. You can compute like x d3 is equal to x mod 10. Both of them will give you the last digit of the given number. Got it? Okay, done. Now see, we have separated d1, d2 and d3. You want to check that out? You can print them actually. Print d1, print D2 and print D3. Let's print them. 5, 4, and 5. 5, 4, and 5. Let's give here a different number, say 1, 2, 3. So it will print them 3, 2, 1. 3, 2, 1. Okay. So we have separated the digits. Now what is our next point? What is our next task? Our next task is to compute the sum of the cubes of these digits. And how do we do that? Okay, declare a variable sum, and in that we want to store d1 cubed. That is, we have to use that double star that represents raised to the power, right? So d1 raised to the power of 3 plus d2 raised to the power of 3 plus d3 raised to the power of 3. That will be our sum. And then let's print this sum and check it out. Print sum. So it will be printing like 3 cube plus 2 cube plus 1 cube. That is 9 plus 8 plus 9, sorry, 27 plus 8. 27 plus 8 is 35 plus 1, 36. Okay, okay, done. Now what do we want to do? Now the decision making part, right? Now we want our program to do a comparison of this sum and the original number. Now where is that original number? We lost it actually, isn't it? Because we are changing the value of x. See here, for example, if I right now print the value here, print the value of x here, you will see that x is equal to the first digit, that is 1 here. So it will print a 1 here. This is your x, but that is not our original number, right? Since we are changing the value of x in our program, and since we need the original value of x at some point of time later in the program, so what we want to do is we want to store a copy of x intact. Okay, so for that reason I'm declaring another variable n, and there I'm storing this x. Now if we change x, we still have a copy of x actually. So here right now, if instead of printing x, if I print here n, you will be seeing the original number 123. Got it? Okay. Now what we want our program to do is we want our program to do a comparison first. That is whether this n is equal to the sum or not. Okay. So if both of them are same, then we want our program to display Armstrong number. Otherwise, we want our program to display not an Armstrong number. And how do we do it? Obviously, we have to use if-else statement. Okay, let's do it then. If the given number is same as the sum that we have computed, in that case, we want our program to display Armstrong number. Otherwise, that is, if it is not the case, see, only two options are there, right? So we have to check only one condition. And if it is not the case, if that option is not true, obviously the other option will be true. It's just like, tossing a coin. Now, if you toss a coin, you see the head on the surface. You do not need to see, actually, you do not have to turn the coin to see what is beneath that, head. Obviously, it will be tail, isn't it? The same thing here. If the number is equal to sum, you're printing Armstrong number. So obviously, if it is not equal to the sum, certainly it is not an Armstrong number, the other option, right? So you just display it like print Armstrong number. Not an Armstrong number, actually, not an Armstrong number. And that's all. That's your program. Let's run this program and check it out. Not an Armstrong number. So I have given the number as 120. These intermediate results I do not need. So for that reason, what I'll do is, okay, in fact, what I'll do is I will delete these lines so that you see the main program on the same screen, in the same single screen, without actually scrolling them. Okay, let's run this program once again, and it shows that it is not an Armstrong number. Okay, great. Then we know that like if we give the input as 153, we should get this is an Armstrong number. Okay, let's try it. It's still saying that not an Armstrong number. Why? N is equal to the sum. Where is my sum? I deleted this sum actually. Sorry. Okay, let me undo that thing. Yes, see here, I deleted this computation of sum. That's why this problem was coming. Okay, I don't want to delete this, isn't it? Yes, right. Now it will work. Not an Armstrong number. If I give here 153, it will show me it should show me this is an Armstrong number, right? If I give here, say 407, it should show me this is an Armstrong number, right? And if I give here any other number, say 675, the restriction is that it should be a 3-digit number, okay? And it is not an Armstrong number. There are, I guess, 4 Armstrong number or 3 digits Armstrong number. Okay, that's all, I guess, about this program, isn't it? I guess if people have now understood what is if-else, if-else, and how to use them to write programs. Now it is time for check your understanding part. What do you think will be the output of this program? If false, print this will be printed, else print this will not be printed. Print, are you sure? Now see here, point of interest is that this print statement, see the indentation. This print statement, you should realize that it is outside the if-else block. Because of how do you know that? Because of this indentation. If you remember my, the explanation of the topic, there I said you the importance of this indentation, right? Indentation are used in Python to represent a separate block of code. Now see here, this is the else block, this is the if block, and this particular line is not within the else block, it is not within the if block. So it is outside the if-else statement. It means no matter whether it is, whatever it is, I mean, this if-else doesn't have any impact on this particular line. So no matter what result this if-else produces, this particular line will always be executed. Okay, so based on that hints, can you predict the output? Pause the screen, think for a moment, and try to predict the output. Let's see what will be the output. If false. Now see here I have written if false. Now since it is a false, now your point is it is a false here. Now we know that in if-else statement, if the condition becomes false, then the else part gets executed. So in this case, instead of writing a condition, you directly have written the result of the evaluation of that condition, and the result you have written explicitly as false. It means this if part will be skipped and the else part of this if else will be executed. It means if you execute this program, this will not be printed. That should come, I mean, this print will be this will not be printed, will be executed. So as a result, you will see that thing on the output screen. And after that, as I said, no matter whatever it is the output of this if else, this particular line will always be executed, right? So as a result, along with this particular line, you will also see are you sure on the screen. Let's run it and check it out. This will not be printed. It is coming from here. And are you sure is coming because of this particular line. Understood? Now see, instead of see the importance of indentation here, if I give here some space, that is if I press a tab, then see this print is now coming inside the same block. This vertical space, they do not mean anything in Python, but this horizontal space, they mean they mean a lot in Python programming. Okay, so you see here, as soon as I give a tab in front of this print statement, it becomes a part of this else block. So it means what? This particular line will be executed whenever the condition is false. So in this case, if I execute the program, you will not see the difference in output because it is in the else block, and since you have written here false, else block will only be executed. But the thing is, instead of writing here false, if I write here true, again you see true, I am writing T in capital RUE. Okay, so if I write here true, it means, see here, you could have written there a condition, and what Python will do, it will first execute that condition, it will first evaluate that condition, and if that condition turns out to be true, Python executes the if block. But here, instead of writing there a condition, directly you have written that true. It means actually you have reduced some task for this Python interpreter. But ultimately, Python will see here a true, and since it is a true, it will execute the if block here, right? Okay, if I execute this program, you will see this will be printed on the screen. This will be printed on the screen. Now see here, this time it is not printing this are you sure, because it is in the else part of the, or it is within the else block of this if else statement. Now see, if I remove again this indentation, then what will happen is this will become, this will go out of the, this will not be, this will no longer be a part of the else statement or the else block. So as a result, even if it is true, then also this particular line will be executed because it is not part of the if else statement anymore, right? Okay, let's execute. This will be printed. It is coming because of this line, and then print are you sure is coming because it is anyhow it will be executed because it is not part of this if else statement. You got my point? Okay, done. Okay, now suppose I show you this particular program and ask you people to predict the output of this program. Then you'll be, you'll be surprised to see a 10 here, isn't it? Because till now we know that here we have to write, like whenever we're writing if, and the next thing should be a condition or maybe the result of a condition, as we have seen just now, right? That is, either you can write true or false, or you can write a condition there that ultimately gets evaluated to either true or false. But here it is a 10. I mean, what is this? I mean, is it wrong? No, it is not wrong. Why it is not wrong? Because you see here in Python, and not only in Python, in any programming language, all the numbers, any number other than zero is considered as true. And obviously, in that case, 0 is considered as false. Now, as soon as I give you that hints, or as soon as I give you that information, you should be able to predict the output now. Now, see, as I said, any number other than 0 is true. It means what Python interpreter will see here, if 10, it means if true. And since it is true here, you know that the if block will be executed. As a result, it will display, these will be printed on the screen. What about this line, print are you sure? And again, you see here, because of this indentation, this print statement is not part of this if block, right? So no matter whether this condition is true or it is false, this particular line will always be executed. It means on the output screen, if you execute this program, you will always see are you sure, no matter what you write here in this condition part. Are you getting what am I saying here? Yes. Okay, let's see. First, verify whether 10 is considered as a true or not. Okay, let's see that. This will be printed. 10 is most probably considered as true, and that's why it is showing you this will be printed on the screen. Now let's give here a 0 and see what happens. As I said, 0 is false. It means this particular line will be skipped, and since you have not written any else block here, nothing will happen if the condition is false. However, no matter whether that condition is false or true, as you know, this print will always be executed because it is outside the if block, right? Because of it, this indentation. Okay, let's execute and check. Are you sure is only coming because this particular line is only coming. See here, are you sure, which is not part of this if block. Clear? Okay. Now I said any number other than 0 is true. Is a negative number also considered as a true? Let's see it. Minus 90, it is true. Since it is true, it will print, this will be printed on the screen. This will be printed on the screen. And this one is coming, as you know, because it is not part of this if statement. Okay. Now say if I write here minus 90.00009, what will happen? What do you think? Again, it's a number other than 0, isn't it? So since it's a number other than 0, it means it will be evaluated as true, or it will be considered as true. And since it is true here, it will be executing this if block, and as a result, the same output you will see on the screen. Same output, right? What if I give here a very small number, not a 0, but a very small number, 0.000004. This is a very small number, but it is not 0. Since it is not 0, it will again be considered as a true value, and as a result this part will be executed, and obviously this one will be executed no matter whether it is true or false. So as a result you will see the same output actually. Understood? Okay then, that was the main point here. It's an important point. Now what was that point? That any number other than 0 is true, 0 is considered as false. What about this program? Now, if you have understood the previous check your understanding, then you should be able to answer this question. Pause the video, try to predict the output and see whether your prediction is right with the actual output. Okay? Now see, x is equal to 5. And here we're writing if x mod 7. Simply that we have writing. We are not comparing x mod 7 equal to 0 or x mod 7 equal to 1. Nothing like that. We simply have written x mod 7. That's all. And inside this if block, we have written print I am a boy. Inside this else block, we have written print I am a girl. Now what do you think will be the output? Now see, x is equal to 5. 5 mod 7. What is 5 mod 7? 5 mod 7 is 5. Now what we have learned, just learned that any number other than 0 is true. So see, if it is 5, it means it is true. And if it is true, it means this if block will be executed. And if this if blocks gets executed, only one statement it is there. And as a result, I am a boy will be printed on the screen. Let's execute and check it out. I am a boy. Now what do you think? What value should I write in x that produces I am a girl without changing any other thing in the program? Okay. Here, if I give a number which is completely divisible by 7, that time it will produce I am a girl. Let's say I give here a 14. Now what will happen is 14 mod 7. 14 mod 7 is equal to 0. Since it is 0, it will be considered as false. And since it is false, it will go to the else part and it will execute the else block of the program. And inside this else block, you have written print I am a girl. So obviously it will print I am a girl. I am a girl. Understood? Okay. Now, what about this program? What will be the output of this program? If you execute this program, what will happen is x is equal to 100. 100, you have written if 100 is greater than or equal to 80. 100 greater than equal to 80, that is a true condition. So as a result, whatever it is there inside this if block, it will be executed. Up to this point, things are clear. But the thing is, the next one is in this program is again an independent if statement. That is, for this if, there is no else. Okay, so it means no matter whether this condition was true or false, this particular if will be executed always. And same thing is true with this one also. No matter whether the condition of this previous if statement was true or false, this if will always be executed, because this if is by any means, this if is not related with this if or this if. Got the point? So in that case, if you know that thing now, what will happen is now that x is equal to 100, 100 greater than 80, true, so it will print greater than 80, and then again it will execute this if statement and it will check if 100 greater than or equal to 60 or not. Again, that is a true condition, so it will print greater than 60. And again, it will come here and it will check if 100 is greater than equal to 40 or not. Again, that is a true condition, so it will also print greater than 40 on the screen. And then you have written here else, but 100 greater than or equal to 40. Since it is true, it will execute this if block and it will skip this else part. Now see, this else is a part of this if else statement. Okay, like see here, only the last one is an if else statement, but before these two, the previous two were only if statements. Got it? So as a result, this will be printed. If you give x is equal to 100, as a result, this will be printed, this will be printed, and this greater than 40 will be printed. Let's see. Greater than 80, the first one, greater than 60, the second one, and greater than 40, the third one is printed. Okay? Okay, and what if I give here a number, say less than 40, say 32. In that case, this one will not be printed because 32 is greater than or equal to 80. It is not true. This one will also not be printed because it is greater than or equal to 60. That is also not true. But this one, x is greater than or equal to 40. 32 is greater than or equal to 40. That is a false statement. Since it is a false statement, it will execute the else block. And inside that, you have written print less than 40. So as a result, it will print less than 40 on the screen. Less than 40. Understood? Okay. Now, this is one important point with respect to Python programming language, okay? And what is that point? None of the if, elif or else block can be empty. You either can omit them completely or have to use the pass keyword. What I mean is, see here, here I'm saying you that none of the if, elif or else block can be empty. It is different from not writing an else block. See here, this if statement here, it doesn't have a else block. It doesn't have an else block, right? So it means we are omitting the else block completely. That is possible. That is allowed in Python. Okay, that's what I said. You either can omit them completely or have to use the keyword pass. I mean, see, you can omit it completely, but you cannot write something like, okay, let's do it here. If x is 34, x is greater than 90, print it will rain today. Otherwise, I'm writing here pass. Okay, let's remove those things from here. And again, remove this else. What I mean is, see, you can write something like this, no problem. X equal to 34, x greater than 90. If it is true, it will print, it will rain. And if it is false, we do not want our program to do anything. So it is completely fine. Although it is not producing any output, but then also it is completely fine. You can omit the else block completely. That's okay, fine. Now, say for example, now here, if I give 340, it will work. It will rain today. It will rain today. It means the program is not showing you an error when you don't write an else part of a if statement. That is allowed. Okay, but what is not allowed is that, okay, you are writing an else, but the thing is that you don't want to write anything inside this else. Okay, and then you try to execute this program. In that case, your program will not be executed. What it will show you is something called as syntax error, unexpected end of file while parsing. It means the moral of the story is that Python is not able to interpret what you have written. Okay, that's the point. Again, why it is happening? Because as I said, no, none of the if, elif or else block can be empty. But here what I'm trying to do is I'm trying to write an else block, but inside that else block I didn't write any statement. At least one statement should be there, right? And so suppose for some reason you want to write an else block or you want to write a if block, but the thing is that you do not want to write any executable instruction there. Okay, so in that case you have a way. Yes, you have two ways actually. One is that you completely ignore this that particular block, and another way is that, okay, you write the block and then there inside that you write this keyword pass. Pass means what? Don't do anything, simply like that. Okay, so now if I try to execute this program, Python will not object it because pass is an instruction for Python. It means you have written an else block which is not empty, so it is allowed, right? So in that case, the Python will execute the program and it will generate the output. Now see, if I give 340, anyhow it will print, it will rain today. But suppose I give here a small number, I mean a number which is less than 90. In that case, say for example 34. 34 greater than 90, that is a false statement. So as a result, it will come here, else part. And here inside that you have written only pass, not print pass or anything like that. Okay, you have written only the keyword pass. So as soon as Python sees that, it means it is no operation instruction, sort of. Don't do anything. Okay, so it doesn't do anything here, and that's all. That's the end of the program. So as a result, you will not see any output here. It is same as actually not writing this else part. Okay, both these ways will work. So it depends, it depends upon you actually what you want to write and how you want to write. Okay, I just told you one feature here. That's all. Got the point? So it is an important point. The important point here is that you should remember that yes, none of the if, elif and else block can be empty. And the second thing is you either can omit them completely. That is, okay, as the way I'm writing here. Okay, that is, there is no else part at all. But if you want to write a else block or a if block or a elif block, and you don't have any instruction to execute inside that block, in that case what you have to do is you have to make use of this pass keyword. Understood? Okay, now. Okay, if you have understood the previous example, then just try to predict the output of this program. X is equal to 34, x greater than 90, print it will rain today, otherwise pass, print this is after if else. Yes, obviously you predicted it right, I guess. So it will print 34 false, so pass, nothing will happen. But this particular print will always be executed as it is not part of this if else statement, right? So this is after if else, this will be executed. Although this condition is false, it's coming here, it is passing this this block, I mean without any operation, no operation statement here, but that is the end actually of this else block. So when the control reaches here, it will see it's a print statement which is outside the scope of this previous if else statement. So as a result, it will execute this particular line, and as a result you will see this on the output screen. Understood? Okay. Now what about this program? What is the output of this program? Let's see here one point. Why did I bring this program here? One point you should remember, that till now whatever the programs we have written inside this if else block, we have written only one statement like print something and like that. But it is not a necessity. It means inside this if block or inside this else block, you can write as many valid Python statements as you want. Here we have written inside this if block, we have two statements. And how do you know that? Just by looking at the indentation. When you are writing a block, your indentation should be right. Otherwise Python will object it. Okay, so for example here, if I don't give it, it will create a lot of confusion for the Python interpreter, and it will not be able to execute the program. It will not be able to parse the program. Okay, so for that reason you should you should write the indentation in a proper way. And if you're using an editor like Google Colab or Jupyter Notebook or Spider, then this indentation will be taken care of automatically until and unless you by yourself don't mess up with the things. And so you don't need to worry much about writing those indentation by yourself. Okay, now let's come to the point here. The point is that you in a if block or in an else block or inside an elif block, you can write as many Python instructions as you want. Okay, not only one. I mean, it is not necessary that you always have to write, or you always can write only one instruction. No, it is not. No such things. Okay, inside that if block or else block or if elif block, you can write as many valid Python statements as you want, as I'm showing it here. Okay, if it is understood, then the next question is, what is the output of this program? Let's see. Let's say a is equal to 1, b equal to 1, x is equal to 14. Now here what we're doing is, you should realize that the program will always be executed from top to bottom. Okay, so that way, suppose a is equal to 1, it means in the RAM it will create a container where it will store 1 and it will call that container A. Similarly, b, another container created, 1 is stored. X is equal to 14, another container created where 14 is stored. Now if x mod 7, that's all. If x mod 7, now what is x? X is 14, 14 mod 7 is 0. So it means this is 0, it means this is false. So since it is false, it will go to the else block of the code. So inside this else block, we have written print world and b is equal to b plus 1. Both these two statements are inside the same else block. How do you know? Just by looking at this indentation, right? So it means if you execute this program, because of these values of x and this condition, the controller will reach here and it will print world on the screen, and it will increase the value of b by 1. Whatever it was previously, that b, it will increase that value by 1. And at the end, what you're doing is you're printing a, printing b. It means a is still 1, so it will print 1 here. B is, since you have increased this b equal to b plus 1, since you have increased this b by 1, it will print b is equal to 2. So ultimately the output will be world, then 1, then 2. Let's see. World 1 and 2. You got the point? What do you think will be the output of this program? Okay, let's execute the program, see the output, and I'll give you a justification of the output. Okay, let's first execute the program. X is equal to 9, rainy day count is 10, dog day out or dog day count is 15. If x is greater than 34, 9 is greater than 34, that is false. Immediately it will go to the else. Print, it will not rain today. So it is coming, it will not rain today. And then, so I can take my dog for a walk. So I can take my dog for a walk. Dog day count is equal to dog day count plus 1. Whatever it is the previous value of dog day count, which was 15 plus 1, 16, that you want to store back in dog day count. And Then you want print not certain about tomorrow. So not certain about tomorrow is coming because this print is outside this if block as well as this else block. So this one will always be executed no matter what, whether this condition turned out to be true or false. So as a result, you will see this not certain about tomorrow on the screen. And after that, what you're doing is you're printing the rainy day count and dog day count. So rainy day count, you have not changed anything, so it will print 10. But dog day count was increased by 1 because of the execution of this else block. Because inside this, you have written this line, dog day count is equal to dog day count plus 1. So as a result, since you're printing dog day count here, it will print 15 plus 1 is your 16. Now see, you might be thinking, okay, I have increased rainy day count also by 1, but why it is still 10, not an 11? Because you see, because of the value of this x. Since x is 9 is greater than 34, it is false. It means this entire block was skipped. It means this entire block was not executed. Since this block was not executed, this statement was also not executed. Since this statement was not executed, it means it was the value of rainy day count was not increased. All right. Okay. Let's now give a value which is actually greater than 34. In that case, what will happen? Rainy day count, now it will reset the value to 10. Dog day count is 15. So 90 is, now you're checking if x is greater than 34. Ultimately, you're checking if 90 is greater than 34 or not. It is a true condition. Since it is a true condition, it will execute all these 3 instructions one by one. First, it will print, it will rain today. Then it will print, so I shall get my umbrella with me. And then it will increase the value of rainy day count by 1. So previously it was 10, now it will make it 11. And since this if block is executed, this else part will be skipped completely. And then after this if else, the next statement is not certain about tomorrow. So on the output screen, along with this line and then this line, you will also see not certain about tomorrow. And after that, since you're printing rainy day count, so it will check what is rainy day count. Rainy day count at this point will be 11, so it will print the 11 here. And dog day count, it will not be increased, so it will still be 15 there. Okay, let's see the output. It will rain today because of this particular line. So I shall get my umbrella with me because of this particular line. And then not certain about tomorrow because of this particular line. And then 11 is coming rainy day count, but initialize, which you have initialized as 10, but inside this if block, again, you increased it by 1. So as a result, this 11 is coming. And then the next one is 15, which is coming from print dog day count. Dog day count initialized with 15. But since this was a true condition, only this if block was executed. Else part was skipped. So as a result, this particular line was also skipped. And as a result, when you print this dog day count, it will print the initial value, which was 15. That is 15. Okay, understood the point? Okay guys, then that much only in this part of the video. If you like this video, please press that like button and also share this video with your friends. If you think this video could be useful for your other friends, then please share this video with them and subscribe the channel. I really need a lot of subscribers. If you think the content is good, then please do not forget to subscribe. Okay guys, then that much only in this part of the video. See you guys with some new content in the next part of the video. Till then, have a nice day.